First, I'd like to thank our AIA Austin COTE chapter committee sponsors, the Indoor Weather Professionals, Hill and Wilkinson General Contractors, and Pilgrim Building Company. And then we also have, we're lucky to have Kingspan as our event sponsor, and I will send it over to Brent Tringa for a little presentation from Kingspan.
Perfect. All right. Well, thank you, everyone. I really appreciate the opportunity. Just want to take a moment to talk a little bit about what we have called our Planet Passionate program, and it directly aligns with the AIA Architecture 2030 in terms of a holistic look at reduction in global of embodied carbon. So Kingspan, being a global insulation, primarily insulation manufacturer, building product manufacturer, has made 4 major commitments between now, 2020 and 2030, holistically looking at our impact. One of those buckets being energy. So a few of the targets I'm just going to go through, and then I'll show you kind of the progress we've made, maintaining our net zero energy goal, which we reached in 2020, a 20% renewable energy generation across our entire business energy footprint, and then upping that to a 60% direct renewable use on those sites by 2030, installing renewable energy on all of the sites that we manufacture that we holistically own across our global footprint. And that's about 166 sites. The next bucket or target we have is carbon, but both operational and embodied. So the goal is to be a net zero carbon manufacturer by 2030, looking at zero emission company cars across our global fleet, and a 50% reduction in our primary supply chain intensity. And this is the one that's going to bring the embodied carbon and the GWP of our products that we actually produce having the most impact. As we all know, the suppliers upstream have a really big impact in the supply and the embodied carbon footprint of our products. The third being circularity. So this is a big one, obviously keeping our products in the circular ecosystem. So basically a zero waste to company landfill by 2030. So across, in certain regions, specifically in North America, this has been a big lift, but our team's done a fantastic job at doing this. Recycling 1 billion PET bottles, so the water bottles that we all drink globally, taking those, recycling them back into our manufacturing process, and then our quad-core technology utilizing that PET feedstock as a polyol that goes into our insulation and running that by 2025. The last goal, water is a primary, a critical resource. It's not energy. It's not an intense part of our process in many of our installations, but we do look to basically collect 1 million liters of rainwater by 2030 and be engaged in 5 ocean active cleanup projects by 2025. We already have one involved in Spain that actually part of our PET collection. And I'll leave it with this. You know, we set a 2030 target, but these are very aggressive targets that we're actively engaged in. You can see the performance and where we've already made some significant improvements just in the first year of the program for 2020, looking at where we've made some strides. So we look forward to making continuous improvement and delivering better, more efficient, lower embodied carbon products to meet the goals and design challenges, which you all will be seeking and obviously discussing on today's call. So with that, I'll turn it back over to the team and look forward to a great discussion.
Thanks for that. And thank you, Kingspan, for sponsoring this event and getting most people lunch today. So for the remainder of the event, we're going to watch about a 25-minute video that's kind of stitched together from the AIAU event. And then we'll transition to a panel discussion with the folks we have on the call. The video might be a little soft, the sound might be low, so make sure you turn it up if you can't hear. And then give you a half a minute to turn that down so we're not yelling in your ear once we come back.
The building sector is the single largest consumer of energy and producer of greenhouse gas emissions in the United States and globally. The 2030 Challenge, when we issued it in 2006, was immediately adopted by the American Institute of Architects. It provides architects and designers with a path to reducing the building sector's energy consumption and emissions, reaching carbon neutral design as standard practice by the year 2030. The AIA+2030 Online Series will teach and inspire you to meet the 2030 Challenge targets. First, by understanding and applying design strategies and efficient technologies, and then by adding renewable energy resources. The series is taught by industry experts and will offer an in-depth look at the key design elements and systems that affect building performance. By completing this series, you will have the tools, the methods, and the resources needed to meet the 2030 Challenge targets.
Other ways of measuring energy from a design, from a building. Energy Star score being one, ZEPI being another. Energy cost budget is yet another. I don't want to dismiss any of them. They're all necessary and good. I do find that some of them have a bit of translation that is necessary from a design and a practitioner's perspective that can sometimes be more complex than we need to be able to drive the fast change that we have to drive right now. So I, in general, talk in my head, maybe it's only my own personal head, but I talk about these things in a sort of an absolute metric way and a relative metric way. Miles per gallon on a car or energy use intensity is a number. It's an absolute number. It's either close to zero or it's high, and that's relative to a particular use type, but it's an absolute number. The other types of measures, be they cost, be they ZEPI, be they target finder, are relative to a scale of some kind. And actually, I think the 2030 commitment is another relative scale. So it's relative to CBEX, as we talked about earlier, but it's a % reduction from something. So those are good things to set up as parts of our professional landscape and very important to have, but they're hard to be they're hard for design teams to understand how to act related to them, relative to them. My personal feeling is that the absolute numbers, like EUI, are much more actionable. The relative numbers are useful for communication in different forums and for different purposes, but from a design perspective, if we set a goal that is a number, we can track how carefully we're getting to that goal. And as I said earlier, the closer that goal gets to zero, the better off we are.
I think a small firm has definitely some advantages when it comes to energy modeling because we can make the decisions, just flat out make them. A large firm might have difficulty. There might be politics involved, or how many levels of hierarchy are there for getting the correct answer to move forward. We don't have those problems. Small firms, there's advantages and disadvantages, but one of the advantages is the decision making can be really clean and really straightforward. The tools involved with this can be perfectly suited for small firms. They can be free. They're very easy to use. There's really no barrier to entry. You can take it literally from a free program on up. The large firms have larger budgets and they can play with bigger programs, but really there's a program for every size firm, and that's really not a barrier to getting involved with this. The key thing that these programs will tell you is how you're doing on the design. So in particular, you could look at a baseline design initially and then add, let's say, better perimeter decision making, which would be windows, insulation systems, things like that. Better mechanicals, looking at how renewables impact the design, how passive house standards impact that, and starting to see where the bang for the buck is on each of those decisions. What's the result? What's the cost involved? And this is on a program, let's say, that's free. A program we like to use is called HEED, which is developed by UCLA, and it's a public program, cross-platform, so really, again, no excuse not to use it. And that thing does all those design decisions and gives you the impact of what those are relative to your EUI number. And there's also a section in there on how it works for economics. So you get an understanding of, you know, hey, I just did this with these windows, and that's got this yearly payback. You know, is it 4 year? Is it 5 years, 6 year? And you can make decisions. You don't have to do every single thing green or sustainable, but you can see like, yes, this is important to me to do, and this is where the cost is for that. That's what I'm doing. And you can go to the owner and explain that very, very clearly. You have really good metrics to use with them in their decision making. Architects in general are the quarterback of the project because we're going to be calling the plays and, you know, kind of directing how we want that to turn out. And we are looked at to do that. And it becomes very important in energy modeling or in energy design to try and hit a target that we're trying to go after, to be able to direct the different pieces that are involved in a very complex project. All of our construction projects are complex. There are no easy ones. And we need to have the right people doing the right thing at the right time. And we're the ones that really need to coordinate that. If you're not doing it, no one else is going to come to the rescue. There's no one down the hall waiting to come in and do it. And when we use these energy modeling tools, we have the confidence because we actually know the numbers, we know the results, we know the impact of these different design decisions, and we're able then to, with confidence, say exactly what we need to do to get to our target that we're after. We get a feeling that we need to bring someone in when we've kind of hit the wall on our knowledge base, which is fine, and that's a good thing to do, is to understand what your limits are and to bring in a consultant to help. Currently, we're working on a project that's a net zero, fairly large home, and it's a difficult task. And we are now bringing in a consultant, a mechanical engineer, to really figure this out. But on a lot of projects, we find that we're able to fully understand it with the tools we have now, with the energy modeling software and the way the CAD programs work. We can see how the sun is moving through the house at different times of the year, different hours of that day. There's definitely going to be times where you need to understand where your limits are and to bring in consultants, which is not a bad thing. And I think it's key to let the owner understand that up front as well, that you may be bringing in a consultant at this point, so that it's not a surprise to them.
Why is it so important to bring all these people in early? The more decisions that are made by the right people early in the design process, the more efficient they'll be, the more optimized, the more they are integrated, those solutions, so they won't be VE'd out later. So they really make the performance happen. And even though it might upload upfront cost to have everybody come in early, those decisions that are made well at the beginning save money at the end. So we need to find a process that allows for that early decision making.
We use computer simulation of various elements of the building, the energy performance, the daylight performance, thermal comfort. It really does help refine some of our designs and inform us.
Schematic design is really when you want to do most of your load reduction analysis. So you do a computer simulation of the building's performance, trying to guide the design decision very early on. Then you start doing more serious iterative modeling runs. And the goal there is to really try and optimize the performance of the building so that you've driven the loads in that building, the heating and cooling loads, as low as you possibly can.
We still have to do fundamentally great design. We have to figure out the innovations, and then the computer simulation will help us refine it. But it does give us the ability to try things before the building is built and save us a lot of money.
So as we're changing the way we approach energy efficiency for the building, it also changes the economics. And it's really the balance of those two, obviously, that a commercial owner is going to want, how they can get the most return while reducing their costs.
Kim, I wanted to talk to you today about HKS's commitment to the 2030 challenge. And, you know, we signed on to that years ago, and we realized when we did that we as the architects could no longer rely just on the engineers to contribute to the energy savings of the buildings in order to meet the 2030 challenge goals. And so, we recruited you a few years back to really help us understand design performance modeling and how we could integrate that into our design process and make better decisions on the front end of the project that would reap us projects with energy efficiency toward the target of the 2030 challenge.
Well, that's, I really commend you for doing that because it's fairly progressive. A lot of our colleagues in the past have really taken the approach of let's leave the engineer out of this until we've figured out the design. And I think that's really, there's two things that led to that. One is that we as engineers really didn't want to spin our wheels. The early design process is really iterative and a lot of change happens. So we kind of had the attitude that we'd save money if we waited until the design had settled down before we got involved. And instead of us working alongside the architects, we were working behind you. It's really dangerous when we get out in front of you, then that's when we really lose money and time when we have to redo things. I also think that there's a certain reluctance of architectural designers to get engineers involved in that creative process because traditionally we're the guys that say, no, you can't do that. And I think we as engineers need to be a lot more, yeah, we can do that. Here's what it means if we try to do that. And help inform the design process and work alongside you rather than, as I said earlier, behind you.
Traditionally, one of the frustrations that we had as architects is that many of the engineers, they want to have all the information before they'll take any action. And one of the things that we really learned from you is that we can do some design performance modeling with very, very little information up front that is so impactful.
As I like to say, there's only 3 pieces of information that I need to help you start doing some of this design performance modeling. Where is the project? Not its street address, not its zip code, really its area code. What kind of building is it? Is it a hospital? Is it a school? Is it an office building? Roughly how big is the building? Is it 1,000 square feet, 10,000 square feet, 100,000 square feet? That helps us kind of figure out how important the building envelope is going to be because then the skin to volume ratio becomes involved. And once again, that's information that we can give you in the design process that also helps us. It informs our part of the design as well and helps us make good decisions early on that we won't have to change later on down the road.
Mm-hmm. You know, one of the things that we learned that was so amazing is just how much the architectural decisions influence the energy consumption of a building. And you know, we play this energy modeling game that we created, and we find that the teams can identify energy efficiency measures that will save up to 25% oftentimes without ever even touching the mechanical systems. And so it is amazing the impact that we can have. One of the things that we're really trying to do into our design process is to have an alignment meeting with senior executives of any given building project and help them understand that setting an energy budget for a project is just as important as setting a construction cost budget.
You know, this idea of goal setting and defining what the objectives of the project are is so important because if a team knows what's expected of them, they're a whole lot more likely to be able to deliver on that. So as you said, you know, if the team knows this needs to be a $160 a square foot core and shell office building, they can design to that. If they know that the energy budget needs to be 40 kBTU per square foot per year, there's a whole lot more likelihood that they're going to get to 40 kBTU and compared to, well, we're finished now, what's the energy usage going to be?
Yeah. You know, I find it very rewarding to design to a budget like that, and to really know that I have a goal out there to achieve a certain benchmark, and to work hard to shape the design, you know, set the insulation thicknesses, set the sun shading devices at the right dimension, play with the window to wall area ratio, maximize the daylighting in the building. Those things are very rewarding when you can see the results.
Without a doubt. And I think one of the great things about the 2030 commitment is it helps us define what those goals need to be. It's a really clear path for us to say, okay, here's where the average is, and we need to be 70, 80% better than that. And that's a challenge. It's without a doubt a really steep challenge. And as you said, unless we work cooperatively, where each member of the team gets a chance to have some leverage on that performance, we're never going to get there. It's always got to be a team effort.
Part of the integrative design process is getting all the stakeholders in a project involved from the start. And I touched a little bit about an alignment meeting with the senior executives just a moment ago. But really, one of the reasons for doing that is because they are the voice that everyone is responding to. The entire development team, the entire design team is responding to that particular client. And if they've voiced certain goals, then the team will respond as well. And it's important that teams work collaboratively and work in an integrative process in order to really achieve the levels of energy efficiency that we're targeting.
Well, one of the things that we really try to do in a lot of commercial buildings is drive down the amount of energy that's being used by the lighting system. Because not only is that energy that's being used by the lighting system, that's energy that the HVAC system has to consume to take the heat of the lights out of the space. And as I like to say, in a lot of cases, the lights that we put into our spaces are really little electric resistance heaters. So one of the strategies that we use is to lower the lighting power density. Another strategy that we use is daylight harvesting. Well, in projects that we've worked on where we don't get the interior design as part of that decision making, if the interior color selections, the reflectivities and the colors themselves soak up a lot of light, you can get into a really bad situation. So in this one particular instance that comes to mind, we were working in a fitness center, and the cardiovascular room is one of these great big cavernous rooms that's got a lot of cardiovascular machines, stair steppers, things like that in it. And because of that, the owner was very interested in having a black rubber floor because it really soaked up the vibration and the noise associated with all that pounding and stepping that was being done on those machines. And the lighting system that we had chosen was a really nice direct indirect system where we had pendant light fixtures that shone up onto an exposed white painted ceiling, exposed roof deck, exposed ductwork, all of those sorts of things. And at about 40% through the construction process, one of the owner's representatives changed, and he was brought through, the new representative was brought through the space to sort of look at it. And he said, you know, I was just in this really nice restaurant where all of the ceiling was painted black, and then the lights just came down out of the ceiling, and you couldn't see any of those round things that you got up there, and you couldn't see the wrinkly underneath side of the roof deck. And the contractor said, well, we can certainly fix that for you. And they painted all of that stuff black. And when that happened, it just sucked the life out of the space and the light. The workers started having to carry around flashlights so that they could actually go around in the space. And that's a perfect example of this siloing that we sometimes get into, where people make decisions that they think are perfectly legitimate that don't really understand what those reactions and those impacts are going to be.
We know that energy efficient design saves our owners and tenants money throughout the life of the building. But doesn't it cost more up front? What about the incremental costs of high efficiency equipment and systems? Well, it certainly doesn't have to. Let's look at opportunities to lower not just operational costs, but first costs as well.
What we found is that high performance buildings aren't about adding a green covering at the tail end. That's always expensive, and that's what gives building owners and other folks in the building community the impression that green buildings are expensive.
What we try to do is look at all of these systems, how they fit together, and then see what elements are redundant and what can be eliminated.
We may spend more on installation and windows, be able to make a smaller heating system, and then operate it at much lower costs over time. So that's the concept we call tunneling through the cost barrier.
We're so conditioned to thinking that very efficient must cost more, but through integrative design, you can tunnel through the cost barrier. At first, the cost goes up as you save more and more energy, and it goes up more and more steeply. That's called diminishing returns. But if you keep going, you often get to the point where you can eliminate mechanicals, for example, and then the cost comes down more than you paid to get there. And why should you get there the long way around when you can tunnel through the cost barrier directly to that destination?
One of the things that I have found fascinating is that our contractors will oftentimes price things on a singular system basis. And I'm learning more and more that instead of pricing, let's say, a lighting solution, several options, and pricing that in silo, you really have to price and evaluate things as bundles. And there's just an importance of, in other words, taking credit for if you do a really low lighting power density project, you should be saving money from the start, but you should be even saving even more money just due to the reduction in the loads in the mechanical system. So any thoughts you have on how to bundle systems and that approach?
You know, that's a great idea, is this idea that if you combine a lower lighting power system with a daylight harvesting system with an intelligent selection on window to wall ratio, where you can see that the lowest cost and the best lighting solution is not necessarily a lot of windows or really clear glass. So these analysis tools that we do allow us to change and look at the results of what does it do when you change the lighting power density. Well, if we lower the lighting power density, we lower the HVAC system cost, but we may not be getting enough light in through the windows in order to satisfy the minimum lighting levels that are required in the space. So if we increase the window size, that might actually drive the cost of the HVAC system up. If we change the glass so that it has different solar gain and visible light transmittance characteristics, that can also ripple into the size and cost of the HVAC system. So these things are always interrelated. There's a real synergy that exists between them. And unless you are constantly looking at the impacts that they have on each other, you can end up going down a blind alley and thinking that you're saving money and then maybe making a terrible design mistake.
Many of our clients, let's just use speculative office developers, for instance, they're ultimately trying to create an investment vehicle, and they're eventually going to sell that product to an institutional investor who's looking for a return on investment. So when we sit down and have conversations with them and help them understand that setting an energy budget on their project and developing a low energy intensity building is really creating a better investment vehicle for them to sell to institutions.
When you think about it, it's all part of the overall cost model. If you decrease operating cost, you increase income, and if you increase income, you increase value, and that's what the investor is after, and that's what the developer is looking to deliver on, is that good investment. In the same way that a building owner who occupies the building, like a higher education or a hospital healthcare system, the cost to operate that building is something that actually drains money away from what their core mission is. Is it education? Is it healthcare delivery? And if we can design these buildings so that they're low energy costs to operate, that's just that much more money that can go to their core mission.
So we've all heard the expression, the definition of insanity is doing the same thing over and over again and expecting different results. In this case, it really applies. We need to drastically alter our design process to have drastically different performing buildings. And integrative design process allows us to do that. It really achieves that end. When the whole team works together on a problem and dedicates themselves to achieving an outcome that is set at the beginning and tracked throughout, we can achieve those carbon neutral buildings. We've seen it. Analysis informs that design process from the beginning. That's a key ingredient. And the architect can act as that master collaborator. We are truly uniquely qualified to do that.
Okay, well, sorry about the technical difficulties there for a little bit, but that was some snips from the AIAU online course. If you want to see the rest of that, I'm sure it's available on AIAU. So now we'll move on to the panel discussion. I also posted in the chat a link to our previous AIA 2030 commitment webinars, but I'll let the panelists introduce themselves. Let's start with Ryan. Oh, you're muted.
I'm Ryan Bollom. I'm a principal at Low Design Office. We have an Austin-based office here. And then my partner, DKO CSR, leads an African-based office. So we have an office in Temagana, and he's actually currently teaching at Penn State. And our practice is really focused on building sustainable and social, equitable projects for a variety of clients.
Well, it's great to have you here. Jenny, if you want to do a brief introduction.
Hi, everyone. Yep, I'm Jenny Heim. I'm a sustainability specialist at Studio 8 Architects here in Austin. We also have a San Antonio office, and my colleague Umesh is also with us.
Okay. Umesh, do you have anything to add?
No, I think Jenny pretty much covered it. I'm Umesh Atre. Hi, everyone. I know a couple of you, but yeah, we do a lot of sustainable design work and excited to be here today.
Well, Jenny and Umesh, if you want to kind of talk about how you set sustainability goals in-house, be something that I'd look forward to hear about.
Sure. Yeah. So, I think before becoming signatories of the AIA 2030 commitment, Studio 8 didn't really have a formal process after signing on to this. So we worked on sustainable projects. We worked with a variety of clients who had internal sustainability goals, or we set them with them during the process. But we have formalized that with the AIA 2030 commitment. So I think one of the process for us now is to do the integrated design process, which was part of the part of the video. So we are still working on that and trying to integrate that into all of our projects, but it's trying to involve all of the decision makers in the firm and on the project early in the process, and getting everyone in the same room. And so I think on projects specifically, that's our process, but also just setting up that process across all projects is getting those decision makers on board at the beginning. Umesh, do you have anything to add?
I mean, another thing that we've been working on, it's not complete yet, but you know, when you start a process or a new project, you basically have to think about the design, obviously, but also, you know, what kind of specifications are you looking at? Because every project is going to have a set of specifications that will have to be followed. So we are basically putting together something called a green spec, which, you know, regardless of whether a project is pursuing LEED or AGB or any certifications, if your firm can set certain minimum standards as far as building efficiency goes, I think that can go a really long way towards, you know, making sure that, you know, again, regardless of whether you have a LEED or any other certification that your project might be pursuing, you're still making sure that you're meeting certain efficiency goals. And that, again, like Jenny said, it has to be something, you know, like a top-down approach. So whoever is your upper management has to buy into these things and, you know, make sure that you know, something like this can happen. So again, that's really key, is that integrated design process, right? So making sure that these things become part of your standard design practice. I think that really is key.
And Ryan, I know there's only two folks for you, Ryan, but how do you kind of make those decisions?
Yeah, so it's a little bit easier since it's just DK and I, and then we collaborate and bring on people at certain times, and so we can have anywhere from, you know, 2 to 10 people working between the two spaces at any one time. And a lot of times we're working in construction, where I'm at a construction site right now, and so in some ways our the field of people we're overseeing increases to another environment. And so it is easier to make the top-down decisions because we approach every project, you know, with sustainable and resilient strategies as drivers, and social strategies as drivers. And so the benchmarks from 2030 certainly are helpful to set goals, but then it really depends on the client and what their attitude is, and the budget they have, what they're willing to spend up front. And so we work through kind of initial discussions with them, and then try and create our sustainability goals for the project that we can then track. And then it's, you know, especially when you get out on site, on a construction site, you realize that no matter how you design things, the way the construction is carried out can bring a whole new level of unsustainability, or just kind of destroy the process altogether. And so the people who are on site, you have to make sure that they understand the goals that are set out through the project, and that in order to execute the things efficiently, we really have to have a construction process and a construction flow that is really considering the design process, because you can backtrack a lot. And then, I mean, our work in Austin is very different than our work in Africa, which is much larger scale. And I think it's like, you know, one of the things we think about, or we're constantly thinking about in relation to our African work, is I think the African population right now is about 20% of the world's population, but the UN projects that number to be about 40% by the end of 2100. And there are billions of people, of new young people are growing in Africa every year. And so we have to think about social ideas in terms of job growth, how we harvest materials, how we create buildings. And so there's a much larger spectrum of things we're looking at in those typologies and spaces.
Yes, with that kind of process, in talking to clients, do typically have like a checklist or something formal that you can refer back to? And this will be kind of a question to all participants, but Ryan, you can kind of start that off. I just kind of want to know, like, after setting those goals, how do you kind of keep on those goals and make sure that everyone on the project team knows exactly what you're trying to hit?
Yeah, it becomes difficult. And so I think we do it in terms of energy use, if we're trying to provide energy, rainwater collection, what we're doing for on-site permeability, daylighting. And so I think those are like the key cores. We're looking at really passive strategies. We're trying not to, especially at the beginning, we're not thinking about the products nearly as much. We're trying to think just how can we design a smart space to achieve, things for healthful living. And then yeah, we'll work through from there. And we use Climate Studio to try and model as a plugin to Rhino, where we model things in 3D. And then I think at points, what we'll do is print out spreadsheets showing like, all right, this is where daylighting is coming from, or energy gains or losses are coming from. And we can look at very specific parts and really components of each part of the design process. And then we will review those with clients and consultants.
Studio 8 folks, how do you kind of talk to your clients about it?
Yeah, I think, well, we have our internal goals, right? And we've committed to the 2030 commitment. But when talking to clients, we have a variety of clients. So I think, like design, we try to get to know our clients, right? Who are they and what are their goals, and trying to understand where they're coming from, because we have we want to get the lowest EUI as we can, but that may not be their priority. And so understanding what their priorities are, I think, is one of the biggest things to do, which is we do in design all the time, right? But also, so how we can cater to them in that way, and how we can communicate those goals and setting those additional goals that may not be at the forefront of their priority list at the beginning. So I think that's what we try to do. And we try to, whether there's a LEED or an AGB certification, which we do a lot of, it's not always something that's part of every project. So trying to integrate some of that early energy modeling. Internally, we use Sapphira. So because you can use SketchUp and use that as a plugin, it's a really easy, I think, low cost and just low barrier piece of software that everyone pretty much can use, because a lot of folks in our firm are using SketchUp at those early conceptual schematic design phases. So we try to incorporate that, and then just knowing how those impact those numbers overall. And then, of course, sharing that information with the client in whatever way we think will be the most effective and impactful. And then, going through that process throughout design.
And I would
just to, sorry, go ahead. Okay. Just to add to what Jenny said, all of these things that we are talking about today, again, it comes down to what is the client looking at. So, that first picture that you present to the client is something that we have always found is really important, because if you show something, if you show a 3D rendering of your building and the client loves it, then it's really going to be difficult to go back and change it. So all of these analyses, all of these integrated design process items that we're talking about is something that needs to happen beforehand, right? So you need to make sure that your design already incorporates all of the sustainability strategies that you want to get incorporated, right? Before it gets presented to the client. So that's something that we strive to do. And many a times, depending on your project budgets and your schedules, it's not always possible. But like Jenny mentioned, we have been using this tool called Sapphira, which almost every architecture studio that we work with uses SketchUp. But then there's also Revit, right? There's tools which are getting incorporated into Revit, which can be used as well. And Perkins & Will actually recently released another really easy to use energy modeling tool. So that used to be a challenge until a couple of years back, but we don't see that as a challenge anymore. And really, if you're talking about large firms versus small firms, I think even small firms are at a point where, it's starting to get really easy to start incorporating these into your standard design processes. And yeah, payback, depending on your clients, you have to make sure that you're giving them the best budget. You're trying to meet their budget, but trying to get a good design within that budget. So looking at low-hanging fruit, what makes the most sense. And then Austin Energy, I mean, we are in a utility which actually has a lot of rebates that are offered as well. So many times clients are not even aware of that. So we make sure that we tell them that, okay, if you use LED, then depending on how many kilowatts you save on an annual basis, this is how much you would probably be getting back from Austin Energy. So that is something else that we try to educate our clients as well.
And yeah, just to add to that, I think, for us, especially the residential side, everything for the client, they, in a vacuum, they want as sustainable and efficient as possible, but then it comes down to the constraints. And so everything becomes a value, a judgment. And so, especially with these tools, the software that can help us to show those things, that helps. But it's very difficult as technology is changing. We're learning new things about technology and the products we use to really, for me, one things I find difficult is to really place a value for them. It's like, well, how much better is this product versus that product, or this type of weather barrier versus that type of weather barrier, and what does that actually do to the life of my building and the quality of the construction? And so those things I'm hoping become more like the studies become more readily available. I know they're out there, but that becomes a more difficult sell, I think, for us at least to some clients.
Yeah, and I guess like at the end of the video, they're talking about like bubbling systems. I guess with those energy models, kind of when you get to whatever EUI you're kind of setting, and talking to like an MEP consultant, do you ever kind of run up against them saying like, oh, like our assumption was we could use this type of system, whereas they're saying that no, it needs to be this type of system? Do you ever kind of get into those types of conversations? Umesh, you're nodding, so I'm gonna direct this to you.
Yeah, no. Again, it comes down to the budget, but yes, we do get into that all the time. And I believe that was one of the things which was mentioned in the video that we just watched, is having a holistic approach to design. So some systems, they may look like they're more expensive if you're just looking at a first cost, but there might be systems out there like VRFs or chill beams, which are actually letting you reduce your overall floor to ceiling heights. And so there's that cost that you have to look at as well. So if a mechanical engineer pushes back on a particular system, I think it is down to architects and the design team to educate themselves about these systems as well, because that is something we don't typically see happening. If someone says something like a VAV, that's probably pretty standard. But if newer systems start getting, newer ideas start getting put on the table by the mechanical engineers, I think a little bit of that responsibility falls onto the design team as well, to make sure that they keep themselves up to date with all these new systems, right? So there is that back and forth which always happens on all projects. But again, knowing that, something like if you have a ground source heat pump, then it's a pretty efficient system. But then what are the costs involved with that? So it really is like an integrative design process, which it always comes back to.
Mm-hmm. Well, we're running up on time, so unless any of the panelists have anything that they want to wrap up with, I'll go ahead and wrap up. Well, thank you all for being here. Let me share my screen one last time.
Thank you for having us.
Thank you very much.
Thanks a lot.
All right, so this was number 2 in our AIAU series. We have our third webinar on May 13th. during the lunch hour as well. It's going to be on health and wellness. And just a reminder to follow AIA Austin on all the social media platforms. I think that's it. So thanks y'all for coming, and hope this was helpful to everyone who attended.
Thanks a lot. Take care, guys. Bye.